I had previously solved this iOS CTF challenge, Frida in the middle, just using LLDB in the terminal. And since I recently got a Binary Ninja non-commercial license, I wanted to use this as an opportunity to learn how to use Binary Ninja. But I ran into a couple little issues. Their documentation for connecting to a remote iOS app, while they worked, in my case, considering I wasn't debugging the main app, I wanted to debug this dilib file. Things were a little bit different, so I'm going to point out those differences here. So first, we're going to open, I'm going to say no here, but anyway, we're going to open that, and it's doing its static analysis. Now then, we're going to go to the terminal, and I'm going to run debug server. Let's see, I'm on the wrong one. So we're going to run debug server, listening on all ports, and wait for, because I don't have this app open yet on the device, as you can see right here. Part of the CTF challenge is if the Frida server is running on the device, when you launch the app, it'll pop up an alert and exit in 5 seconds, and we don't want that to happen. So we're going to wait for here, and the name of the app. Now on the device, I'm going to click to start the FridaInTheMiddle app, and it's paused here because it's hooked by the debugger. So we're going to go back over here. You can see it's listening for a connection. We're going to run iProxy. That will speed up debugging by pushing it over USB instead of over the network, over TCP. So now the next thing we need to do is, let's see, PS Apex. So we're going to get this path right here. This is very important. The path to the app. We're going to copy that. Now we're going to go in here, and for the debug settings, now on Binary Ninja's website, on their documentation, it only tells you to set the IP address, port, and the process plugin to debug server /LLDB. However, to make this work with a remote device, especially since we're not debugging the main app, there's a few other settings we need to change here. So first of all, the input file. This has a local path. It's got to be the remote path. So we're going to change this. And since we're debugging the dilib, this library, we're going to use that there for input file. And as it says here, it's going to be used to find the base address of the binary view. Now then we're going to scroll down here, and the executable path, this is the default. We're going to change this to be the actual executable path of the app running on the device. And a working directory needs to also be on the device. So we're going to just change this from the file to the directory. And now, when we debugger connect a remote process, this should work. Now right now it's in the bottom left hand corner, it says analysis hold launching. I'm going to pause this recording because that's going to take a couple of minutes. Okay, we're back. It's finished loading it, and you can see here in the debug view, it's showing the registers. So now, as far as how I saw the CTF and how we're going to do it now in Binja, we're going to go here to symbols, and we already know from solving this earlier, we're looking for check. And over here, here's that that function, and you can see it does some checks here. This canary socket probe, that's basically testing for if port 27042, I think, TCP is open on localhost on the device, or if it detects that Frida's library is loaded in the process. Else it sets, so if it detects that, it sets this var14 to 1. Now, what we're going to do here to solve this is we're going to jump down here to this return, and we're going to set a breakpoint here. So we go back to the debugger, breakpoints. We have that set. So now we're going to continue. And you can see down here in the bottom left-hand corner, it stopped at our breakpoint. So let's look at our registers. So the return value for a Boolean is going to be an X0. You can show it's set to 1, which is true. So we're going to edit this. Change this to 0 for false. And then we're going to continue. Now, once we continue, looking over here, you can see that we've actually bypassed that check. Otherwise, we'd see an alert here saying Frida was detected, and it's going to close in 5 seconds. So now the next thing to do is intercept that first argument value. But first, we're going to go back over here, and we know from solving this previously that we're looking for a dummy function. And if we set that, we're going to set a breakpoint here. In the debug view, you see we have our breakpoint set. So now we're not paused, we're still running. So over here on the device, I'm going to touch or click this intercept first argument using Frida. So now we've hit our next breakpoint. You can see here in the bottom left-hand corner, we're stopped. So in Swift, you see these Swift symbols right here, like the underscore, $S, blah, blah, blah. That's an obvious Swift symbol. Swift passes large and small strings depending on the type of string, large or small, in X0 and X1. So we see right here in X1, I would expect to see, this is a long string, so we would expect to see that here. But the reality is here is that the address of X1 plus 32 bytes. If you look a little bit below the highlighted line, 32 bytes down, you see the flag starts. It says CTF, and then in brackets, you evaded Frida detection. So we found the flag through a combination of static and dynamic analysis using Binary Ninja.